Okay, so now that we've got the prerequisite material out of the way, we can start talking about stuff that you're actually going to learn this semester in Math 151. So we're going to start by reading limits from graphs. You're probably at least familiar with reading values from a graph, so if, for example, you were asked, find the value at 1, so find f of 1, you would know that you go to your x value of 1, and then you would find wherever your closed dot is. So that's going to be what, -4? So you know how to do that. So now we're going to talk about how to find limits given these graphs. So we're going to start with limit as x approaches -3 from the left of f of x. So -1, -2, and -3. So even though it's not drawn super well, right, this is the point we're talking about. This is where our function is at -3. So to find the left-hand limits are denoted by negative signs in the exponent, whereas limits from the right, or right-hand limits, are denoted by pluses in the exponent. So we go to our point at -3, or our graph at -3, I should say, and we follow it from the left to that point. And it's essentially asking, where is the graph going there? And it is approaching, right, the y value of 4. So we would say the limit as x approaches -3 from the left is 4. All right, now how about -3 from the right? Now we take it from the right and we get closer and closer, and look at that, that's also approaching the y value of +4. So those two would be the same, and if our left-hand limit equals our right-hand limit, then our regular limit, or our entire limit, exists, and it's the same number. So our limit would be 4 at that point. So now for the value at that point, unfortunately, there is no value at this point because there is no closed dot, right? If there's just an open dot and there's no closed dot or anything like that, we have no value. So we would just say D&E. Now we're looking at the x value of 1. So at 1, right, so we're talking about this x value. So we've got 3 kind of points of interest per se. So for the limit from the left, right, we're coming from the left and we're approaching the y value of 1. So our answer would be 1. From the right, so the right is from down here, right? Because that is from the right-hand side that we're approaching the x value of 1. And what y value is that approaching? Well, what is it, -2? Looks like it. So we would say -2. And if you're ever given a graph on like a test or something, it'd be drawn better than this. But unfortunately here, our left-hand limit and our right-hand limit do not match. So if they do not match, we do not have a limit. So we say that the limit does not exist at that point. Now how about the value? Well, we talked about it earlier, right? f of 1 is -4. So -4. Okay, how about the limit as x approaches 2.5? It's not really drawn well enough for you to be super confident, but that looks about like -4, right? And so if you have like kind of just a, for lack of a better term, regular x value, right? There's no, dots or jump discontinuities or anything like that. Then the left-hand limit equals the right-hand limit. So the limit is the thing, and then the value is the same thing. So in a regular point, all the things match. The left-hand limit, the right-hand limit, and the value, they all match. Okay, J is a little weird. I'm not sure how important this is, but if you've never seen it before, it'll throw you for a loop. So if you have a constant coefficient out front of something inside of the limit, you can just pull that out front. So that would be the same thing as saying 3 times the limit as x approaches -2 of f of x. So what is the limit as x approaches -2 of f of x? That's going to be like here. I don't know. Let's just say 3. It looks kind of like 3. So that'd be 3 times 3, which is 9. So our answer to J would be 9. Remember point-slope form. It's an important thing throughout the semester. Just if you were given a point, Your x value goes here, your y value goes here. The slope at that point is here. Okay, now for these kinds of questions for limits. So first thing we always want to try is direct substitution. So that means just plugging in 2 in this case, right? Everywhere we see an x. So 2 squared is 4, plus 2 minus 6, all divided by 2 minus 2. So that's going to give us 0 over 0. 0 over 0 is an indeterminate form, which means it's not an answer, right? It's a sign that we have to do something to get these terms to cancel so that we can get an actual answer. And if you see this kind of a problem, you're going to want to factor it. You should be thinking factor. The giveaway that you want to factor is usually you have like a trinomial in the numerator and like a binomial in the denominator or something like that. If you have something that looks like this, it's kind of screaming like try and factor. So, however you know how to factor is fine. This is how I know how to factor. Very few people, I don't think I've ever had a student who's actually known how to like do this way, called the tic-tac-toe method. I like it. It's how I learned it. But so you get this, and then you get your 2 x minus 2 terms to cancel out. So you're left with x plus 3 with a hole at x equals 2. So, but since we're asked for the limit as x approaches 2 of this, we can just straight up plug that in. So we get 2 plus 3, which equals 5. So if you're asked for the limit, and so it would look something like this. So it'd be like a regular line, right? But then at x equals 2, we would just have a hole in it. But it would, for all intents and purposes, be a line everywhere else except 2. So we have a left-hand limit, right? And we have a right-hand limit, and they match, right? They're pointing to the same point. They're pointing to that hole. But we just don't have a value there because it's an open dot, not a closed dot, right? So we can have a limit without having a value, right? And that's kind of like what we ran into with this point in our graph. So that's what it would look like, and that's how you'd go about solving that. So similar thing here, but you're going to be using a different strategy called multiplying by the conjugate. So the giveaway that you want to use multiplying by the conjugate is you're going to have like a square root, right? You're going to have a square root plus or minus a constant term. And so to find the conjugate, you just flip the sign on the constant term. So the conjugate of the square root of 2x plus 22 minus 4 is going to be square root 2x plus 24 plus 4. So you just literally take that negative, make it positive. If it were positive, you would make it negative. You just flip that sign. So then you multiply by the conjugate divided by the conjugate. And so I'm sure you all are familiar with FOIL. It's a method for, expanding when you're multiplying two binomials together. It's a way to do that. But the beauty of multiplying by the conjugate is you get your outside and your inside terms to cancel out. So you really only have to worry about your first and your last terms. So the first two terms multiplied by each other, well, that's just the same thing under the square root times the same thing under the square root. So that just gets rid of the square root. And then the last, right, that's just negative 4 times positive 4. That's negative 16, right? So then we leave our denominator in this unfactored form for now. And then we can simplify this numerator, right? So 2x, then 22 minus 16 will be 6 plus 6 divided by x plus 3 times square root of 2x plus 22 plus 4. So we can factor out a 2 from this x plus 6, and we get 2 times x plus 3. That x plus 3 cancels with this x plus 3. We are left with 2 divided by the square root of 2x plus 22 plus 4. And remember, this is all still the limit as x approaches negative 3. And when you get a thing in your numerator to cancel with a thing in your denominator, that's generally a sign that you're ready to plug your x back in. So we're going to try direct substitution again. And, I forgot. the first thing you're always supposed to do is try direct substitution. So before we did any of the stuff we just did, you're supposed to try direct substitution. So you would get 16 in here minus 4 divided by -3 plus 3, which would give you 0 over 0, which would be an indeterminate form. I can't even follow my own rules. So, and then you would get an indeterminate form, which is 0 over 0. So then you would do all of this. Always remember to try direct substitution first. It will be points on exams and quizzes. So now we can plug in -3. So we literally just take everywhere we see a negative, or everywhere we see an x, and we plug in a -3. So 2 times -3 plus 22 plus 4, and then 2 divided by all that. So that's going to be square root of 16 plus 4 all under 2. And so that's going to be 2 divided by 4 plus 4. So that's going to be 2 divided by 8, which simplifies to 1 over 4. So that will be our answer there. That's how you multiply by the conjugate. Okay, other stuff. So this is just like silly stuff, but I don't know. It's relevant. Might be a little prerequisite-y, you know what I mean? So f of z, you just, everywhere you see an x in f of x, you plug a z in instead. F of 2, everywhere you see an x in f of x, you plug in a 2 instead. That simplifies to 5. If you have any questions, feel free to email me.